Today, we want to talk about the triple scalar product because we brought it up yesterday. I kind of glossed over it, and then I realized actually that's kind of cool. So now I want to talk about it. So here we have a drawing of three vectors, all starting from the same point. We've got A, B, and C. And the three vectors we can see have been extended to A and B have been extended to a parallelogram. Actually, any pair of these vectors has been extended to a parallelogram. And then when we do it three-dimensionally, this is a parallelepiped. So notice the two vectors, that any two vectors are forming a parallelogram. Any two of the vectors A, B, and C form a parallelogram. The three vectors form a parallelepiped. I think there's an extra E in there, and it always throws me off. So all three vectors together form a parallelepiped. Finding the area of a parallelogram is the same thing what we do for finding the area of a rectangle. It's just length times width. Or in the case of a parallelogram, we call it the height. We don't just multiply the sides. We need the height of the parallelogram. To find the volume of a parallelepiped, we do the same thing that we find to find the volume of any other thing. We take the cross-sectional area, in this case, the area of the parallelogram down there at the bottom, and multiply by the height. That's just how we find volume of an item with a constant cross-sectional area. That's when we get to multiply. So here are the things that make this cool. One of the things that we either recall or we're learning for the first time, because I can't remember if I mentioned it before, is when we were talking about the cross product. We know that the cross product form of two vectors forms a vector that is perpendicular to both of those vectors. So if I find the cross product of A and B, those are clearly the ones that I want to find. I'm going to make the vertical because it's easy to draw it here. So in the cross product, A cross B, we know that A cross B is perpendicular to both A and B. So the things that we know about the cross product are that A cross B is perpendicular to both A and B. A cross B is perpendicular to both A and B. I like the closed captioning on that. When I say A cross B, it says hey cross B. So we know about the direction of A cross B. That's the thing that I cared about the most at the time because we were describing planes and we were trying to describe planes with one vector. What I almost always forget to mention is that the magnitude of A cross B is the area of the parallelogram formed by A and B. So the magnitude of A cross B is the area of the parallelogram formed by A and B. This was combined into another statement that we had about the cross product, at least the magnitude of the cross product. Recall the magnitude of the cross product was the magnitude of A times the magnitude of B times the sine of theta, the angle between A and B. If we grab A and B and just look at those in a plane, so I don't make my picture even worse. So the other thing that we know about the magnitude of A cross B is that the magnitude of A cross B, oops, still crossed wrong. Is the magnitude of A times the magnitude of B times the sine of the angle between them. So here'd be theta. Now, the parallelogram formed by A cross B, or the parallelogram formed by A cross B, one length is A, the other side length is B. What we need is the height of this parallelogram. I'm going to drop B down onto A. And so that the height of the parallelogram will be the magnitude of B times the sine of the angle, because the height is opposite the angle theta. So this magnitude of B times the sine of theta is the height of the parallelogram. So the magnitude of A cross B is the magnitude of A times the magnitude of B times the sine of theta. That's going to be the area of the parallelogram formed by A and B. So the magnitude of the cross product of A and B will tell you the area of the parallelogram formed by A and B. The way that I wrote parallel pipette, it looks like at the very end, I started to be sarcastic about it. I think it's really interesting in the internet age. We invented a way to type sarcasm. Anyway. So let's extend this out to the volume of the parallel pipette. So I've got the magnitude of A cross B. I got the magnitude of A cross B is the area of the parallelogram. That's going to be the floor of my parallel pipette up here. I've got the direction of A cross B that's perpendicular to the floor. That is the parallelogram formed by A and B. If I want the volume of the parallel pipette, I need to take the area of the floor and multiply by the height. So the volume of the parallel pipette will be the area of the parallelogram, which is just going to be the magnitude of A cross B, times the height of the parallel pipette. Every time I'm unsure about a word that I've written a bunch of times, I'm unsure about its spelling. Writing it multiple times on the same page, that always makes it worse. It makes me think of that X-Files episode where the dude is posing as Mulder. And he's sitting there in a meeting. He's like, well, you misspelled Federal Bureau of Investigation. It's a typo. Twice. So if I'm misspelling parallelepiped, apparently I'm like leaning into it. So hopefully it's right. Anyway, the volume of the parallelepiped is the same thing. We're going to calculate that the same way we calculate the volume of any parallelepiped or any rectangular solid. Length times width times height. So I need the cross-sectional area. That's going to be the magnitude of A cross B. And I need to multiply that by the height of the parallelepiped. So over here on our parallelepiped picture, I don't need to multiply by C. That's too much because C is all at an angle. I need to know the height. So I'm going to take C and I'm going to project it down onto A cross B. And what I want here, is this the right color for this? I think not. Now I'm going to look at the angle between C and A cross B. I've already used theta, so I'm going to use a different letter. And now what I want is the projection of C onto A cross B. So the height of the parallelepiped is going to be the projection of C onto A cross B. I'm using words, regular multiplication. There we go. So the height of the parallelepiped, now I want the side adjacent to the angle between C and A cross B. So that's going to be C, the magnitude of C times the cosine of B. And this is being multiplied by our the magnitude of our cross product of A cross B. So the volume of the parallelepiped is the magnitude of A cross B times the magnitude of C times the cosine of the angle between C and A cross B, otherwise known as the dot product of A cross B and C. I'm not quite sure why I think this is cool. I'm also not sure why I keep forgetting that I think this is cool every semester, such that when we're talking about cross product, never do this when we're talking about cross product. I think that's mainly because I'm always focused on writing or describing planes, tangent planes specifically. So I really need the normal vector to a plane. I think that's why I always forget about this. But then I remember later, it's like, oh, that is kind of cool. Because this goes back to just the very basic parts of geometry, where area is equal to length times width, especially now at this point in your mathematical career. Now we see, because we have calculus, that all those extra formulas for area, those are all just variations on length times width. We're always just doing length times width. There's an old picture. I think it was Archimedes that drew it, where he drew a circle and said, dude, this is just a bunch of rectangles. But that's as far as he got. So some would argue that's like, oh, look, Archimedes invented calculus, which is not the case at all. He could not have done that because he did not have things like algebra and functions and the language that we talk about calculus in. But he had a great idea. It's like, oh, dude, this is just a bunch of rectangles. I don't think he said it that way, but I actually like to think that he did. Whatever the ancient Greek equivalent of, dude, this is just a bunch of rectangles. And then like the people who was talking, to be like, oh, whoa. I don't know what the ancient Greek equivalent of that is. Any questions? Comments? Side remarks? All right, this is what we have left. So this is week 15. But it's also Thanksgiving week. So we've got week 16, week 17, and then finals week. So on December 9th, that's when all the homework is due. Any homework that has a due date, it's due on December 9th now. That's when you lose access to all the homework. Between now and December 9 plus 7, that's when you have to complete everything else. So we're entering final exam season. So more quizzes will start showing up, and that's how on Canvas, and that's going to be our final exam. The problems will show up on Canvas instead of one big chunk in little bits. Those problems will be due on December, what is 9 plus 7? 16. December 16th, Friday, December 16th. All your work has to be done on Friday, December 16th. If you send me an email on Saturday, December 17th, saying, hey, can I get an extension? I will not even see that email until January. Any questions? So more problems are going to show up. I haven't decided the exact number, but as soon as I know, you'll know. I just want to make sure that we hit all the things in the course content.
There is one question I have.
Yes.
The homework for chapter 22, I think it is, or 21. There are no problems populated there. I just want to know if I'm the only one having that issue, or if that was intentional.
No, that is intentional. I didn't put any problems in those assignments. So usually the last chapter, I don't put any problems from there because we don't have time to talk about it. Mostly is the thing. So you will not have to worry about any homework assignments from chapter 21. The reason they're set up as homework assignments is that all the entries in the modules I set up as homework assignments. And then once I did all that, I'm like, oh, wait a second, what if I'm not going to assign problems? And then I just kind of shrugged and said, oh, well, and then it causes confusion. So I apologize for causing the confusion. But you don't have to worry about any problems from chapter 21. Chapter 20 will be our last chapter. Any other questions? All right, with that in mind, since we're entering final exam season and I got to start writing final exam style problems, they're still going to be called quizzes because it's less stressful if I just call them quizzes. I don't know why, it's just weird psychology. So they'll still be called quizzes. They'll show up in the quiz module. I will let you know when the last one has been posted. I'm not going to have a meeting tomorrow because we've talked about all the things what we want to talk about. Next week, we'll have meetings to go over any quizzes that show up, or sorry, final exam problems that show up. But that's going to do it for the new stuff. So no meeting tomorrow. That means that's it for today. That's it for this week. Everybody have a nice long holiday weekend. And I'll see y'all on Monday. Thanks for playing.